In this video, we'll learn about the relational model. The relational model is more than 35 years old, and it's really the foundation of database management systems. It spawned a many billion-dollar industry. The relational model underlies all commercial database systems at this point in time. It's actually an extremely simple model, and that's one of its benefits. Furthermore, it can be queried. By that I mean we can ask questions of databases in the model using high-level languages. High-level languages are simple yet extremely expressive for asking questions over the database. And finally, very importantly, there are extremely efficient implementations of the relational model and of the query languages on that model. So let's move ahead and understand the basic constructs in the relational model. So the primary construct is, in fact, the relation. A database consists of a set of relations, or sometimes referred to as tables, each of which has a name. So we're going to use two relations in our example, and our example is going to be a fictitious database about students applying to colleges. For now, we're just going to look at the students in colleges themselves. So we're going to have two tables, and let's call those tables the student table and the college table. Now, as an aside, there's a healthy debate in the database world about whether tables, relations, ought to be named using the singular or the plural. I personally don't have a stake in that debate. I'm going to use the singular. Next, we have the concept of attributes. So every relation in a relational database has a predefined set of columns or attributes, each of which has a name. So for our student table, let's say that each student is going to have an ID, a name, a GPA, and a photo. And for our college table, let's say that every college is going to have a name, a state, and an enrollment. We'll just abbreviate that ENR. So those are the labeled columns. Now, the actual data itself is stored in what are called the tuples, or the rows, in the tables. So let's put a couple of data tuples in our tables. So let's start with the students, and let's say that our first student has ID 123, name is Amy, GPA 3.9, and she's happy with that, so she has a smiley photo. And our second student is 234, it's Bob. His GPA is 3.4. He's not quite as happy. And typically, of course, a table will have thousands, maybe millions, even sometimes billions of rows, each row containing a value for each attribute. In our college table, let's suppose we have, well, of course, we're going to start with Stanford in the state of California, and Stanford's enrollment is 15,000. We'll include our Cross-Bay rival Berkeley, again in the state of California, and Berkeley's enrollment is a whopping 36,000. And last of all, we are going to not be West Coast biased. We'll include MIT in the state of Massachusetts with an enrollment of 10,000. Now, of course, there's going to be, again, many more tuples in the college table and many more tuples in the student table.